Good morning, students. How are you? As in the previous video, we had discussed about some practical units of length, and in the discussion of practical units of length, we had discussed about the measurement of large distances, and we had used for the units used for that measurement is astronomical unit, light year, parsec we had defined, and for the measurement of small distances, we have defined micron, angstrom, X-ray unit, Fermi. Then we have discussed about range of length from very small to very large. We had discussed, and finally we had found the ratio of the lengths. Now today is very interesting discussion, that is time, that is measurement of time. Measurement measurement of time. Measurement of time. Students, time, what is time? Time time is a renowned puzzle in our society. If you ask about time from a little child, probably he will answer you that what is time. And if you will ask what is time to a very knowledgeable intellectual person or a philosopher, then quite he is unable to explain time, because time has a broad area. So the question has puzzled the philosophers and saints also. The real answer for this question was given only in last century. Answer for this question. Answer for this question was given in last century by Einstein. Einstein had answered this question, and he told that time is nothing. Time is only the thing that clocks measure. It is simply what's a clock reads. What's a clock reads is called time. What is the reading of a clock, that is called a time. Now there is a question in the mind, that what is clock? What is clock? It is simply, the clock is the instrument which measures time, and clock can be settled or understood by rotation, by a rotation of earth, rotation of earth on its axis, and hourglass, hourglass. You have seen in movies that such type of glass is there. In old movies, it was kept and sand is placed in this. That is hourglass. Pulse count, pulse count, thickness of thickness of geological deposits. Thickness of geological deposits. With the passage of time, sedimentary rocks deposits one over the other. That thickness of that sedimentary rocks or sands are going to be deposited one over the other, and the layer is formed. The thickness of that layer can be also considered for the measurement of time. It is also considered as a clock. Products of radioactive decay. Products of radioactive decay. Products of radioactive decay. Radioactive substances, uranium, thorium disintegrates due to its radioactivity. And what is the disintegration? Remaining product after disintegration, the amount of that product can be used also for the measurement of time, and it is also considered as clock. Vibration of cesium atom. Vibration of cesium. Vibration of cesium atom means from these techniques for the measurement of time, what the techniques we had used, 4 or 5 techniques I had detailed in front of you. In all the techniques, you are observing the fact that a periodic things is going to happen. The changes which is occurring is periodic, and wherever the periodic trends are followed in nature, that can be considered for the clock or measurement of time. So this is the basis for the measurement of time, and that things can be considered as clock. Now, some practical units of time. We are going to discuss some practical units of time. Some practical units of some practical units of time. So for measurement of time larger than a second. For measurement of time larger than a second, first one is 1 minute. 1 minute, and this is equal to 60 seconds. Second one is 1 hour. 1 hour, that is 60 minutes, that is 3600 seconds. Third one is 1 day. 1 day, and it is equal to 24 hours, and it is equal to 24 into 3600 seconds, and this is equal to 8.6 into 10 to the power 6 second. 8.6 into 10 to the power 6 second means 24 hour is equal to 24 hour is equal to 8.6 into 10 to the power 6 second. 8.6 into 10 to the power 6, 10 to the power 4 second. 1 year. 1 year is equal to 365.25 days. 25 gives 366 days. 0.25 gives 366 days in a leap year, and it is equal to 365.25 into 8.6 into 10 to the power 4 second, and this is equal to 3.156 into 10 to the power 7 second, or you can write it as pi into 10 to the power 7 second. This is the total number of seconds in a year. 1 decade. 1 decade. It is equal to 10 year, and it is equal to 3.156 into 10 to the power 8 second. 3.16 into 10 to the power 8 second. Now 1 century. 1 century, that is equal to 100 years, and it is equal to 100 into 3.156 into 10 to the power 8 second. That is equal to 3.156 into 10 to the power 9 second. This is equal to 1 century, which is 1 century is equal to 100 years. 1 millennium. 1 millennium, that is equal to 1000 years, and 1000 years, that is equal to 3.156 into 10 to the power 10 second. These are the larger time than the second. Larger time, to measure larger time than a second, these practical units, the seven practical units which we had studied, can be used. Now to measure time smaller than the second. To measure time smaller than a second. To measure time smaller than the second, what are the practical units we use? First one is 1 millisecond, and it is equal to 10 to the power minus 3 second. Next one is 1 microsecond, 10 to the power minus 6 second. Third one is 1 sec, and it is equal to 10 to the power minus 8 second. Fourth, 1 nanosecond, 10 to the power minus 9 second. These are the smaller times than the second. These are the practical units to measure time smaller than a second. These practical units are used. Now we will discuss the range of time interval. Range of time interval means from how much larger time to how much smaller time we can measure, and what is the ratio of the larger time to the small range of larger time to the range of a smaller time, and what is the time for our heartbeat, time interval between human heartbeat, lifetime of a proton, lifetime, first of all write the heading, range of time interval, range of time interval in second, range of time interval in second, lifetime of proton, lifetime of proton, it is approximately equal to 10 to the power 39 second. Age of universe, age of universe 10 to the power 17 second. Human life, human life expectancy, that is 10 to the power minus 10 to the power 9 second. 10 to the power human life expectancy means what is the average time for a human being to be in this on this earth. That average time what is calculated is 10 to the power 9 second. 1 year 10 to the power 7 second. 1 day 10 to the power 5 second. Time interval between human heartbeat, time interval between human heartbeat 10 to the power 0 second. Time of blinking of eye, time of eye blink 10 to the power minus 1 second. Period of visible light wave, similarly things are period of visible light waves, it is approximately equal to 10 to the power minus 50 second. Period of nuclear collision, period of nuclear collision, it is equal to 10 to the power minus 22 second. And Planck's time, Planck's time is the time for transition, the time for transition from lower to higher and higher to lower energy, that is Planck's time. It is equal to 10 to the power minus 43 second. So you are observing that Okay, the range of time interval in second is from 10 to the power 39 to 10 to the power minus 43. Now imagine from how much big to how much small. These range of time we used to measure by the clock or various time scales are used for measuring that time interval, and this is the range. The of ratio of longest time to the shortest time. The ratio of longest time to the shortest shortest time, and is given as 10 to the power 39 to 10 to the power minus 43, and it is equal to 10 to the power 82. So we can conclude that the time period for human heart is not too small and not too big. It is in between the small and big. Interval between human heartbeat is neither too large nor too small. Human heart beat is neither too large nor too small. That is equal to 10 to the power 0 second. 10 to the power 0 second means it is in the midway between the largest value and the smallest value. The next heading is range dependent time measuring techniques. Range dependent time measuring techniques. Range dependent time measuring range dependent time measuring techniques. So to measure a small oblique ordinary time intervals, we use sand clock, oblique pendulum clock. As ordinary time is measured by the help of sand clock or pendulum clock. Sand clock I had dealt previously. Very long time intervals measured in terms of years. That is long time intervals. Long time intervals are measured in years by the help of rotation Long time intervals are measured in years by the help of rotation of Earth. Rotation of Earth about the axis is used as the technique for the measurement of long time intervals. Very long time intervals, very long time intervals like age of our Earth. Very long time intervals like age of the Earth is measured by the help of radioactive radioactive clock. We had discussed earlier about radioactive clock. What is radioactive clock? And very large time interval like the age of any planet, the age of a star, all these things can be measured by the help of radioactive clock. A small time intervals are measured with quartz crystal clock. A small time intervals, a small time intervals can be measured by the help of quartz crystal clock. Measured by the help of quartz crystal clock. And very small time intervals by the help of quartz crystal clock, and very small time interval of the range 10 to the power minus 7, 10 to the power minus 8, 10 to the power minus second, minus 9 second. These time intervals can be used by the microwave oscillator, can be measured by the help of microwave oscillator, measures, lasers, etc. Very small time intervals can be measured by the help of lasers, measures, etc. Microwave oscillators, microwave oscillators, etc. Detailed studies about these techniques you will do in your higher classes. Now at present time only you have to consider about these techniques, how these techniques are used for the measurement of time intervals. How these techniques are applied, you will study in further later on classes. So that's all for today, students. Tomorrow we will discuss about certain numericals based on various techniques of measurement of length, mass and time, and after that we come to our topic, that is dimensional analysis. Thank you, students. Have a nice day. Thank you.